heat waves, drought, tornadoes, hurricanes, floods, blizzards, bitter cold. Extreme weather has an incredible impact on people across the globe. On Mount Washington, our scientists brave some of the worst weather on the planet to improve our understanding of our warming world.
All right, good evening and welcome everyone to Mount Washington Observatory's Science in the Mountains program. My name is Brian Fitzgerald and I'm the Director of Science and Education here at Mount Washington Observatory. And joining us this evening to share their insights from the highest weather stations in the world is Dr. Baker Perry, Professor of Geography and Planning at Appalachian State University. Thanks so much for joining us for tonight's program. For those of you who aren't already familiar, the Mount Washington Observatory is a nonprofit member-supported organization whose mission is to advance the understanding of the forces that create Earth's weather and climate. And the way we do that is through operating our weather station with around-the-clock weather observation 24/7, 365, by conducting research and product testing projects, and by delivering educational programs. Alrighty, well, if you have any questions for tonight's speaker and you're joining us through Zoom, don't forget that you can use the Q&A button. You can find that just at the bottom of your toolbar there. We'll leave some time at the end of tonight's program to make sure we get some questions in. If you're joining us on Facebook on the live stream, thanks for joining us there. We won't be able to respond to many of your questions live during the program, but we'll see if, make sure our our summit staff will be able to respond afterward. If you'd like to connect for a Zoom connection next go round, you can always connect and register over at mountwashington.org/SITM. Alrighty, well, before we get going with our program for tonight, I'd love to kick things off with a brief poll, and I will do that in just 1 second. So for those of you who are joining us on Zoom this evening, I have 4 questions for you for tonight. First and foremost, curious where you're joining us from tonight, whether it be a state within New England, perhaps you're joining us outside of the region, or perhaps even outside the country. Love to know where you're joining from tonight. If you can just take a few moments to respond, we'd appreciate that. Also curious, I know lots of you returning Science in the Mountains viewers, but we're curious to see if we have any newcomers tonight. Let us know. And then we have a couple questions, perhaps the toughest trivia questions we've gotten from a speaker thus far in the series. Some good, challenging trivia tonight. What is the average barometric pressure at the balcony on Mount Everest at over 27,000 feet? 280 millibars all the way up to 560 millibars. And then finally, the average freezing level rise in the Everest region in Nepal rose approximately how many meters between 2005 and 2019? Was it 30 meters of elevation? Was it 50, 75, 100, or 125 meters in elevation? Take just a few more moments here. Over half of you have responded. That's wonderful. I'll give it another 10 seconds or so to make sure everyone has a chance to respond who'd like to. And we'll share some results in about 3, 2, 1. Alrighty, we'll end it right there. Now let's go ahead and share some results. Alrighty, New Hampshire, very well represented, tied with outside of New England. Wow, good job, Granite Staters. Thanks for joining. But we have good representation from every state within New England, including outside the region. And we even have a couple folks from joining outside the country. Welcome, welcome. Glad you can join us this evening. Is this your first Science in the Mountains program? Well, 39% of you said yes. This is wonderful. This is great news. We have quite the community here that have been enjoying the programs, and we feel privileged to be delivering them to you. Hope you'll join us for another program after this evening's as well. And then our trivia. What is the average barometric pressure at the balcony on Mount Everest? Most of you thought 280 millibars, and then it really dropped as the number went higher there. And then the average freezing level rise in the Everest region in Nepal. Looks like you were split between 75 and 100 meters, but pretty spread out overall. Once again, some tough questions here, and hopefully we'll get some answers from our speaker tonight. So I'll go ahead and stop sharing. In fact, let's get on with it. Let's get to tonight's program. To tonight's speaker, we have Dr. Baker Perry. Baker, love for you to join us if you're there.
Thank you, Brian. It's a pleasure to be here. Welcome, everybody.
Yeah, thanks for joining. Why don't you take it away?
I'm be glad to. And first of all, I did want to say a little bit about my past history with Mount Washington and New England. As a small child from ages about 2 to 7, I actually lived in Portland, Maine. And those were very formative years, severe winters, and loved being outside in the cold and snow. And I was captivated by the observations coming in from the top of Mount Washington. And eventually I got a weather radio, and I was just dialed into the observations. And so it's been a very formative place for me over the years. And even though I've lived outside of New England for quite some time, I've always found the opportunity and chances to go back and visit. Was just up in December on Mount Washington, and had my family along with me as well. So anyway, thank you for the work that you're doing, Brian, and the entire Mount Washington staff, and those of you who support the observatory as well. All right, I am going to share my screen now. And bear with me while we do. We didn't get it queued up quite right, so we'll back up to the beginning and make my meeting controls disappear. All right, so again, the title of this talk is Elevating Meteorological Understanding on Mount Everest, Installing the Highest Weather Stations on Earth. And this was truly a team effort that you'll hear a lot more about as we go through the presentation. But before we get into that, I did want to send a quick greeting from the mountains of North Carolina, here in the southern Appalachians, where we also had a nice snowstorm. This is the view out my back deck, looking up to Snake Mountain. A foot of new snow with quite a bit of new liquid equivalent up here. And so not quite as far north in New England, but we still do get some snow here in the southern Appalachians as well. Now, after leaving Maine, my family moved to the Andes of Peru and Bolivia. And I know you can't tell or guess who I am in this photo in the upper left, but this was my 3rd grade classroom in Unquillimus, Bolivia, 12,500 feet above sea level. And many major cities in the Andes, such as La Paz that you see here, are heavily dependent on the meltwater from the snow and the glacier ice that sustain these cities. We call these water towers that are so important globally in the Himalayas, which we'll go to next, and of course the Andes and many other mountain ranges around the world. And we know that these mountain ranges, these high mountain regions, are changing very rapidly. They're warming, they're seeing changes in precipitation patterns. Of course, freezing levels are rising, and glaciers are retreating very rapidly. And so that is the context within which National Geographic and Rolex set out on their Perpetual Planet initiative and helped put together the most comprehensive scientific expedition ever to Mount Everest. And 2 of the big questions that our team has been asking: what happens when the roof of the world melts? And so, of course, there are the hazards associated with glacial lake outburst floods, with flooding in general, and mass movements. And that's one important concern and question. The other is the fact that the water towers are vanishing, and that threatens fresh water in many of these semi-arid and arid locations that depend directly on that runoff from the snow and ice, right? So that's the context within which we mounted this expedition in 2019. And, this is a satellite view of the Hindu Kush, Karakoram, Himalaya region, and you can see the huge stores of snow and ice that are present up there that together they really help sustain over 1 billion people in South Asia. So these water towers are absolutely critical. But there's a huge void in data and scientific understanding at the highest elevations, okay, where the bulk of the snow and ice is found. We just do not have weather observations. In fact, there are only 6 stations that we know of above 6,000 meters, and only about 19 between 5,000 and 6,000 meters. Okay, so this is 5,000 meters, 16,400 feet. 6,000 meters is approaching 20,000 feet, a little under 20,000 feet, and so there's a lot of elevation that's not covered by weather stations. And so we don't fully understand the scientific processes, and it really makes it much harder to project future changes in freshwater availability and runoff if we don't understand the processes driving those changes at these very, very highest elevations. So in 2019, we set off on a task of trying to design and plan a network of weather stations. We began partnering with Campbell Scientific, and in some of those early testing days, we were on Mount Washington. In fact, this was from February 2019. And the original goal was just to get all the way to the summit and do a deployment and test up there. And I was trying to get some training in ahead of our expedition. And so I had climbed to the summit on a classic Mount Washington day, 0 degrees Fahrenheit, wind chill, under -40 in that range, and poor visibility. Well, I get up there and I hear over the radio that the snowcat was not able to make it. And so I actually had to go back down to reunite with the Campbell folks at the hotel at the bottom. And we went through the sensors and took a look at everything, and then went up the next day to try to get up. And snowcat again, visibility was too poor. We were not able to make it up. And so we did testing here near the tree line that you see in this photo. I had some good snow falling, and Keith Garrett and the team there at Mount Washington, Keith and Brian, were absolutely terrific, provided some really helpful advice and feedback early on some of the testing. We also went to Nepal prior to the expedition and flew into Lukla. This is really one of the most dangerous civilian airports in the world. You can see why. But to me, this was a big improvement from what it looked like in 1998, which was my first foray into the Everest region. The runway was not paved. It was actually a little bit shorter, and it was very hair-raising, I will say. So the landing this last time was a little smoother. But we had gone into the Everest region to be based out of the community of Forza, which was home of our elite Sherpa climbing team, and did some training with them, and spent time at altitude, and also climbed some ice in preparation for the major expedition later that spring. There were only a handful of us. Mario Pataki, there on the left, is a graduate student at the University of Maine that headed up the ice coring efforts. Tom Matthews, co-lead of the meteorology team with me, in the blue. Then we had Panaru Sherpa, our lead Sherpa, who had 17 Everest summits. Conrad Anker was with us, played a very important role in establishing these relationships and helping get us ready for the task at hand. And then Tenzing Gyalzin Sherpa there was our base camp manager and a very accomplished climber himself. So we got to spend some time on ice, and there's some incredible ice climbing in the Kumbu in the winter months. And here Conrad is showing off his skills, setting up a route that we then took turns on, practiced on. And we also spent considerable time going through tripod designs, testing anchors, familiarizing ourselves with the systems and really getting important feedback from our Sherpa team members during this initial expedition. We of course made it to Kala Patar and had the classic view of Everest in the lower Kumbu Glacier. I mean, the scale, we're talking about 10,000 vertical feet from just what you see in the lower Kumbu up to the summit of Everest. In fact, no, I'm wrong. It's 12,000 vertical feet. We're going from 17,000 up to 29,000 feet just in this frame. Okay, that's the enormity of the task at hand. So we went back in April of 2019 with a much larger team led by Dr. Paul Majewski from the Climate Change Institute at the University of Maine, who had been tasked by National Geographic to lead this scientific expedition. Again, it's the most comprehensive scientific expedition ever to Mount Everest. We had biologists, we had geologists, we had mapping scientists, we had a meteorology team, and of course, we had a glaciology team as well. So tremendous amount to coordinate. Upon arrival, Tom and I began working very intensely with our partners in Nepal. This is Dibas Shrestha from Tribhuvan University. And we had to test all the stations out, make sure the programming worked, make sure the sensors all worked, and the communications. And we had literally 2 days to do all this. And it was very intense. We got everything working the best we could. And then we had to pack everything up because the logistics of getting all of these stations and this equipment into the Everest region were quite complex. Involved helicopters, involved yaks, and then of course, we had to carry this to a certain distance as well. So we went back to Forza, and it looked a little bit different with the snow line there retreating quite a bit higher as it was warming up. And we got to work right away and began installing this first station in the community of Forza. Got all the standard meteorological sensors there. We've also got a Parseval dysdrometer, which measures present weather. And so the type and intensity of precipitation. We've got a weighing precipitation gauge surrounded by a double Alter shield. And this is hopefully a station that will last quite some time and provide a very important long-term record from this part of the Himalayas. Now you can tell from looking at this photo that I'm not a National Geographic photographer. If I had been, the top of this mountain would be within the frame. Okay, so I'm still working on my photographic skills here. Then we made it up to base camp, and here's an aerial view of base camp. It's a small city that sets up on the Kumbu Glacier for about 2 months every year with lots and lots of tents. And this was our home for over a month, being based out of here, going up, sometimes going down a little bit, mostly up higher on acclimatization runs, and setting up weather stations. So there was the Forza station lower down. Then we made it up to base camp, and we installed a station just outside of base camp. We made it up to Camp 2, installed a station there, the South Col, installed a station there, and then we installed the highest station at the balcony at 8,430 meters, 27,657 feet. So I'll take you through part of this journey as we work our way up. We did also install what we call a rover station here on the lower Kumbu Glacier and let it run for a month just to measure the energy fluxes on the glacier surface. And then eventually we moved that off the glacier. But that was some footage there of our team at work. And it was a very valuable training experience setting each one of these stations up before moving higher for our Sherpa team there. Now, it got real challenging as we moved up the Kumbu Icefall. We had to negotiate crevasse crossings, and of course, we had traffic jams as well to deal with. All it took were a few people that were not comfortable on these ladders or topping out on the ladders, and it backed everything up. And so we were waiting here over an hour in this particular traffic jam before we could move up. And unfortunately, it was a bit of a harbinger of things to come higher up. We eventually made it to Camp 2 and installed a weather station at Camp 2. After we had completed this installation, we went back down to base camp to rest up and wait for a favorable weather window to move higher. And we got back to base camp and had felt good about the installation. Things were going well so far. And we knew that this was the highest operating weather station in the world when we got back to base camp. But then the next day, Paul Majewski informed us, like, nope, it's not the highest station anymore. Our Chinese colleagues on the north side just installed a station 50 meters higher. And so he had been in close communication with them, and they were also working on some installations and doing some sampling on the north side in coordination with some of what we were doing. And so it's great that we have some additional data coming in from both the south and the north sides of Everest. From Camp 2, we climbed higher. We climbed the notorious Lhotse face and began building the South Col station. And this was definitely the highest weather station ever installed. And we feel like it's a great spot. It's very exposed there, and I'll show some data and some direct comparisons with Mount Washington actually here in a bit. But after we installed the South Col station, we had to prepare for the next task at hand, which was to go up to the south summit, perhaps a little bit higher was the goal, to install the highest weather station. We were a bit concerned about the winds based on forecasts, and we had identified the balcony as a backup spot if we were not able to get quite as high as we had hoped. And so after installing the South Col station, we had to melt snow. We had to try to eat a little bit and get a little bit of rest, because we left at 11 p.m. That night and made great progress starting out until we got about halfway up that triangular face right there, kind of below the balcony, and we hit a traffic jam, and it was just a crawl. It was moving so slow. Our team was very frustrated, and our progress really slowed substantially. And so by the time we made it up to the balcony, our lead Sherpa Panaru he had pretty much decided that's as high as we were going to go. Just there were too many people ahead of us, and they were moving too slow to be able to work safely up above the balcony to accomplish the objective that we were shooting for, and to get everyone down safely. So at the balcony, we stopped and we got to work, or we tried to get to work. And the first challenge we had working up there was that the batteries for the drill were too cold. They just did not have any power. And so we ended up having to put those under our armpits and in our, crotch, anywhere we could generate some extra heat. And this was something we'd been very concerned about. We'd been sleeping with the batteries in our sleeping bags, but still they weren't quite warm enough. And we had to wait an hour to warm them up. And then they eventually came back to life, and we were able to get the bolts in to anchor the station. Again, not a lot of room to work right there. And you can see there's a cornice on the left that provided a bit of a false sense of security. And so that was the first challenge. Then the next challenge was we were nearing completion here of the installation. We're ready to put the wind sensors on, and realized that the pipes that the wind sensors mount on were not in the loads that made it up to the balcony. And I take full responsibility for not triple, quadruple checking everything, but we didn't get them up. And it was not possible to go back down and get them and bring them back up. We had to get very creative and make do with what we had. And I remember sitting on my pack, just very frustrated that we might miss one of the most important meteorological variables here because we didn't have the appropriate mounts. And I started looking around, and we had just a very light backcountry avalanche shovel with us, and I said, gosh, that handle looks like it might be about the right size diameter. And so sure enough, it was just right, and it was detachable, and there were two pieces to it, and we had to improvise just a little bit, but in the end we did get those handles on there, and they actually have held up. They add a little more color to the station as well, with the orange and the blue that you see right there. And so that was another challenge working up there. My oxygen mask had iced up, and I was not getting enough oxygen coming from the external oxygen tank or coming from the outside air. And that was another major challenge up there. And it's very difficult just to climb and to function up at this elevation, let alone to do any sort of scientific research. So we had a tremendous team that really did a remarkable job in putting this together. All right, so switching gears, some initial results. We've now been able to track the progression of multiple melt seasons during the monsoon. And on the left, we have some data from the Camp 2 station, and on the right from the South Col station. So at Camp 2, during that first monsoon, temperature would go above freezing from time to time during the day, but the average temperature during the warmest month there in the monsoon was around -5. So this is way down in kind of the low 20s. But you can see the black line there in that upper left plot shows that the melt is the predominant process responsible for the ablation, and sublimation, it was fairly minimal during the monsoon. That's in a somewhat contrast to the South Col, where the temperature stayed well below freezing even during the middle of the monsoon, typically averaging around -10 to -15 degrees Celsius. And there is some melt that occurs. Of course, the intensity of the solar radiation is just really, really impressive. And this is one of the sunniest locations in the world. And the intensity of that sunlight is very high as well. And in fact, at times it's higher than what we would expect or measure at the top of the atmosphere because of the multiple reflectances coming from clouds and other snow surfaces there. And so that does drive some melt, even up at the South Col. And we now think that melt may be occurring even on the highest peaks of the Himalayas, including Everest. And I'm not sure how recent this phenomenon is, but that is a really important finding. And this, the fact that there can be, in some cases, substantial melt occurring on these days, even though air temperatures are well below freezing -10, is very important for kind of the glacier-hydrological models that are being used to forecast future water availability. Now, some comparisons with Mount Washington. We presented this at the American Meteorological Society meeting, I think about 2 years ago. And so December 2019, the highest temperature we recorded at the South Col weather station was -23.4 C. Mount Washington reached 5.6. I mean, you can get these thaws in. And of course, I think that 8.3 is the highest ever recorded in the month of December, if I remember correctly. And then the mean temperature was -30, -8.9 on Mount Washington. The lowest temperature recorded that month at our South Col station was -38. And not far off. I mean, Mount Washington hit -30 that month. This again, C. And the December record was -43. So the extremes on Mount Washington can certainly compare to what we have already observed at the South Col station on Everest. The mean wind speed was actually a little bit higher on Mount Washington than South Col, 20 versus 17.9. And the max gust was identical for that month. And since that, we did measure a 66.2 meters per second gust, which is just right at about 150 miles an hour at the South Col. And of course, this is still a good bit below some of the real extreme max winds on Mount Washington. But I'll come back to that in a minute. Our sensors, our wind sensors haven't held up quite as well as we had hoped. And so we've not measured the true highest wind speed up there quite yet. Now, if we take these results and use the observed lapse rates, we can estimate the minimum temperature at the summit was about -47 degrees Celsius and had a minimum wind chill of about -77. Okay, so again, this is not too far off from what Mount Washington has experienced in the heart of winter at times. All right, so we've also looked at some of the trends in the Everest region from reanalysis data. This is ERA 5 produced by the European Center for Medium Range Weather Forecasting. And these data going back to 1980, 1981 show an increase in heavy precipitation, an increase in freezing level heights, and really, for those of you that selected 100 meters as the rise from 2001 to 2019, you are correct, okay? Specific humidity, the amount of moisture in the atmosphere has also been increasing. And this is all evident in these plots here. Now, the stations that we installed at base camp and at Forza, again, have the comprehensive precipitation sensors that have really provided important insight into the precipitation patterns there. And a few key points from this slide: you see a late onset to the monsoon. We had some pretty big snowstorms in the winter months with 121 millimeters or so of liquid equivalent falling during that period, and continuous snow cover, which is not always common in especially the lower regions here of the Everest region. At base camp, we had observations that began on October 2019, and the snow cover is not as deep and not as continuous, perhaps, as one might expect. But it's because base camp is just so heavily shadowed by the high peaks around there. It's in a snow shadow or rain shadow. It still, rains quite a bit, precipitates quite a bit during the monsoon season. But the thing is, nearly all of that precipitation during the monsoon is falling as rain. Okay, something like 75 to 80% of the total precip, even at base camp on the lower Kumbu Glacier, falls as rain. Now, we're not sure how recent a phenomenon that is, but just mid 30s and rain with the snow level just a little bit above you is not a fun place to be during the monsoon. We've also shown that there's really strong seasonal dependence in moisture source regions that highlight a connection to the Bay of Bengal during the monsoon with a lot of those southerly air trajectories. And then for the remaining months, it's more westerly trajectories that come in and provide less of a moisture source into these regions. So those are those 4 panels right there. And this just further illustrates for these specific precipitation events, the 2 major clusters that are connected to the Bay of Bengal are together responsible for well over 60% of the precipitation that falls. During the 2019 expedition, we were actually able to run the highest surface-based radar in the world, and we published a paper on that and caught a snowstorm. It wasn't exceptionally heavy, only about 10 centimeters of snowfall and about 4 inches, but it was a fascinating data set. And one of the things that we learned is that the echotops, at least during this particular snowstorm, were below the summit of Everest for most of the event. Okay. And the air trajectories there were coming off of mainly the Indian subcontinent and a little bit of connection to the Arabian Sea there. So again, these weather stations are already revealing the sources of precipitation to the Nepal, Himalaya, 62% coming from the Bay of Bengal. And this is the moisture that is sustaining the highest glaciers in the world, the Kumbu Glacier that you see on the upper right, and then the lower Kumbu on the lower right, and then of course the South Col Glacier that we see right here. And this is actually leading to additional questions. Our colleagues from the University of Maine recovered an ice core as part of this expedition from right here at the South Col, and they're in the process of analyzing those results. But one of the real puzzling facts is that the surface of that glacier ice right there at the South Col is very old. And we think that sublimation and the really high winds and lower relative humidity, especially even during the depths of winter, are driving substantial sublimation. This is the ice going directly from the solid to the gaseous form. And so some of these glaciers and the snow up at the highest elevations may be a bit more sensitive to loss than we had previously thought. So that's something we're continuing to look in. We're also looking at the winds, and especially what we call dangerous winds, those that can be strong enough to blow climbers off the mountain or lift them off their feet. And there's one particular anecdote from the balcony. I was talking to a guide after we had gotten down from our 2019 expedition, and he had heard that we had installed a station there at the balcony and said, "Oh, well, I've got a story to tell you. I was climbing Everest with clients on such and such day. It was relatively good weather day. The winds weren't exceptionally strong. And I topped out at the balcony, and this gust came from nowhere, lifted me off my feet, and would have blown me off the mountain if I hadn't been attached to the fixed line right there. Right. And so we're continuing to look at the meteorological conditions where these dangerous gusts develop, and our data from the weather stations have already improved the weather forecasts from the global models that are pretty good at the prevailing winds coming through there, but picking up these gusts are a bit more challenging. So the data we know are already improving weather forecasts during the climbing season, and hopefully we'll end up saving lives as a result of that. All right, so where do we go from here? Well, we continue to work with our elite team of climbing Sherpa, and in particular, Lakpa that you see here and Tenzing went up last year to do some basic maintenance. We know that all weather stations need maintenance, especially those in extreme environments. Sensors break. There are all kinds of challenges that develop. So the two of them went up and did basic maintenance on the whole network, and the South Col station was still intact except for the wind sensors. So they took quite a beating, and so this is where we are actively working with the Mount Washington Observatory to come up with some other solutions and think about some creative ways to measure the wind up there and have something that can survive a bit longer. And again, our goal is to operate these stations as long as possible. And really the people that should be doing that are our elite team of Sherpa climbers based out of Forza. And so we're working to build their capacity. And one of our visions is to perhaps in the next couple of years start a weather station academy that could bring people from across the Himalayas into Forza to learn more about weather stations and to develop the capacity to not only install, but to maintain these in other locations around the world. So I do want to acknowledge just our incredible Sherpa team. I'd mentioned Panaru. We had Pasang Kami, Nimarita, Lakpa, Ila, Gyaljan, Fura, Pasang Sona, and then Pinjo Futashi Nima Dawa, who's the first female IFMGA certified guide. This is International Mountain Guide from Nepal. Very instrumental in our team's success. Pimba, Utkin, Tenzing Gyaljan, and Tenzing Gyaljan Sherpa. We could not have done any of this without their incredible support up there. And I do briefly want to just remember Utkin, who died suddenly last year. He's one of our strongest Sherpa team members, and just a real remembrance to him. So I think I'm gonna stop there and say thank you for listening in. I know we have some time for questions still, so let me see if I can stop my share and turn things back over to Brian.
All right. Hey, thanks so much, Baker. That was fascinating. I know I have lots of questions. I will hold most of those perhaps for another time, because we do have a number of questions that have already come in, some really thoughtful ones. And as a reminder, if you're joining on Zoom, just drop it down using the Q&A button that you can find at the bottom of your video screen on Zoom. And again, Facebook Live, apologies. We probably won't be able to get to some of those questions this evening, but you can always reach out directly to us at education@mountwashington.org via email. All righty, so we have some great questions just all around. Dennis right out the gate asks, so how often are these weather stations going to be checked, or how often have they been checked? I think you've mentioned now, at least, the installation and at least one repair visit. How are they being checked, I guess?
That's a great question. And we had intended to go back in 2020 to do some maintenance, but something happened. This pandemic interfered with our plans. In fact, Nepal shut down the entire mountain and nobody went above base camp. And then we were hopeful that we could get back last year, but again, that didn't happen. But we were able to send our two of our top climbing Sherpa up. So really, there's only a short window every year in a normal year that typically opens up, and that's in for a few weeks from really early May till the end of May, that it's possible for people to go up. There's occasionally a fall season, but that's very hit or miss, and it really just highly depends. So we're hopeful that that our Sherpa team members and other Nepali partners will be able to go up and maintain the stations on a yearly basis during the spring climbing season. That's what we're shooting for. And again, we hope to operate these as long as we can. The higher stations, how long that is a big question, but the lower stations, I mean, even from Camp 2 down, I'm optimistic that we should be able to get 5 to 10 years and perhaps longer out of those stations, which would be huge for just meteorological research and establishing a climate record for those locations.
Yeah. So speaking of, not only from the kind of maintenance side of things and checking in, and a question here from Edwin, who's curious about the choices and I guess some decisions around selecting sites. So, was there a particular, I'm sure there's lots of discussions in terms of how to choose the sites, but could you kind of briefly cover, some of the thought process and how you ultimately arrived at the sites that you ultimately chose?
Yeah, I think, there's a combination of accessibility, both longer term accessibility, but also just accessibility during the expedition. And the Forza station, this is the community, the Sherpa community, and having something there, which is fairly high up already, to 12,500 feet. There'd not been any other stations in that community, in that general vicinity. And so that was a logical place. And then base camp, there had never really been a long-term record at base camp. We couldn't set up the station at base camp right on the glaciers, just because the long term, that's just not going to survive. And so we identified a medial moraine up above the Kumbu Glacier that's very stable. We're able to dig in over 3 feet into that and feel very good about that station that we were able to set up for longer term. Camp 2, it was very close. It was right there at near the camp, and so that's was important. And that was just above what's known as the equilibrium line altitude, or kind of the mean freezing level during the monsoon there. And so that's a climatologically fairly significant place. And then, the other two, the South Col, it's a very exposed place up there. We're about a 10 or 15 minute walk from the camp itself. And so again, that was driven by accessibility and just by, there are not many places that are suitable to actually install stations. And then I shared some of the story thinking behind the balcony. We would have liked to have gone a little bit higher, but that was just the site that presented itself because of the circumstances.
Yeah. Well, and speaking of accessibility, I'm sure there's definitely some trade-offs here between making it accessible in this already very inaccessible space. But a question here from Jaden, they're asking, is there any protection? Not only from the elements, but I think Jaden's a little more curious about, is there anything to protect it from other climbers? Have you thought about, interference or
Well,
tampering?
that's a good question. And really all of the stations, with the exception of the balcony, base camp, camp 2, and South Col, I mean, even though they're fairly close to the camps, they're not right there. They're not right in the middle of it. Okay. So you actually have to walk a little ways to find it. And especially the case South Col, I mean, it's the opposite direction of the climbing route. And I think you really have to look very hard to know that something is up there. So, and from my experience, just my own personal experience and watching other climbers, it just takes so much effort to put one foot in front of the other at 27,000 feet. That the idea of just even going 10 steps or 20 steps out of the way to mess with something is, I mean, I wouldn't say it's completely out of the question, but it's unlikely.
Yeah. I can only imagine. So I guess in those circumstances, particularly at elevation, yeah, you'd have to be pretty darn motivated, I suppose.
Yeah, and I should add that our 2 lower stations in Forza and a base camp actually have fences around them, and that's less to protect them from people, but yaks graze through there, and so it provides some protection from a yak using the weather station as a scratching pole or something to
Yeah, I can only imagine. Yeah. Similar but different challenges, yeah, over this way. A question here from Joan, who's curious if you're aware. I know largely you spoke mostly about the meteorological sort of aspect of, certainly you and your team are focusing on. But I mean, Joan's curious if there's other work, even in part of your larger expedition, that was looking at glacier rates of recession, those sorts of things, maybe even lower down on the glaciers on Everest.
Yeah, absolutely. That was a big focus of one of the team. In fact, Aaron Putnam from the University of Maine was involved in some of that. And I think he was on this. I think he had it in Science on the Mountains not long ago. And some of that work is still in stages of analysis, but there have been others outside of our group that have looked at this and have shown that just the elevation of base camp, the height of base camp that surface of the glacier has, there's some evidence that may have declined by about 100 meters since those early expeditions in the 1930s and 1940s. And that's just the down wasting that is occurring. And that's where the biggest changes in the Himalayas have been seen, is just the down wasting as opposed to just the retreat, because a lot of these glaciers extend into, not completely flat, but relatively gently sloped valleys. And so they're just losing ice and mass from the top, and they're getting thinner. And so that's well documented. And our Sherpa team members and the community members tell us about how much less snow and ice there is up on the mountains from when they can remember. And so this is a similar story to what we hear in the Andes, and just how much the appearance of the mountains has changed as glaciers and snow have become less common up there.
Yeah. Well, certainly that local knowledge, even just, hey, wherever you're joining from tonight, that local knowledge is definitely a lot of value there, especially where, the raw data maybe doesn't exist otherwise. There's a lot of value, especially in some of that anecdotal information too. Questions here. A lot of people curious about. So, you had issues with the batteries for the drills way up high. Everyone's curious. Well, wait a minute. Are batteries powering the stations? What's the power situation like for those stations?
Yeah, no, that's a great question. And they are the stations are all powered by batteries, and of course there's solar panels that recharge them, and the batteries that we're using on those stations are specially manufactured for extreme cold, and been tested in the polar regions, and they're also, the battery packs are insulated really well in the pelican cases that they're stored in, and so they've actually held up really well. One of the biggest challenges we've had is that it's actually at South Col, it's snowed more than we expected, and the solar panels have been buried multiple times. And when that occurs, it's hard to keep that charge in the batteries. And so we've lost some data from that. And they have come back to life once the winds pick up and that snow either blows away or is redistributed somehow. They do come back, but that's a challenge. We didn't want to put solar panels up too high because they act like a bigger sail and make the station more susceptible to being toppled or blown over. But then, apparently, being too low is susceptible to burial by snow. And even with the winds that we have up there during the monsoon, when it's snowing as much as it is, the winds are fairly light. And so that was a bit of a new finding for us as well. So.
Yeah, I guess there's probably some trade-offs between building a station that's big enough and tall enough and reaches high, but not obscuring or capturing snow or any extra wind. I can't imagine the engineering challenges associated with some of that stuff.
Yeah.
A number of people, because they're so fascinated by your work, clearly are really curious. How can they look at some of the data you've collected? Is there either public or academic stuff that they could potentially look at?
Absolutely. The data are available on the National Geographic website. And I can probably dig that up pretty quickly here. It may not be before we shut down, but I can get that to you, Brian, and you can, if there's a way to share it with the team, or if you just search National Geographic Everest weather stations, that'll bring you to a real-time page. There's also quality control data that we post on there as well. And if you want to look at the data themselves, and I forgot to mention that the average barometric pressure at the balcony station is 350 millibars or hectopascals. So those of you that chose that, you were right.
Yeah, well, this is great because we got a lot of questions around that, and even so from transmitting the data as well. This is a Ken you might know. How do you transmit that data? How are you actively getting that communicated from the stations to wherever?
Right. So we use a satellite network called Thuraya, which is in the Eastern Hemisphere, and so every hour, at the top of the hour during the daytime only, the weather station, the data logger, makes a connection with the satellite and relays the data to the servers at National Geographic headquarters. And so it's amazing that we have that kind of technology and that we can get data from some of these incredibly remote places. And that's the communications have worked very well on this network.
Oh, that's great. Yeah, because hiking to physically retrieve that data otherwise sounds like quite the load to have to work to.
Mm-hmm.
All right, maybe just time for a couple more questions if you still have the time, Baker. But
absolutely,
this is a good question from Heidi, and in general, what during your work so far on Everest in particular, sort of related to learning about maybe the weather, these weather stations, and all that, what's surprised you the most about your work so far in this area?
Yeah, I think I can point to two things, and I touched on them in my presentation. One is just the intensity of the sunshine, of the solar radiation. I mean, as climbers, we've experienced, I've spent time in the Andes and up high, and certainly had heard stories about how unbearably hot it can be, even at 21,000 feet in the Western Cumb at Camp 2. And so we kind of had these experiences moving up and installing it and being just uncomfortably warm during the daytime in our tents or in our down suits, but freezing at night. But to actually see the data and see that the solar radiation that we're measuring at these stations is higher than what we expect at the top of the atmosphere is pretty amazing. And then also the fact that sublimation, or that conversion of snow and ice directly into water vapor, into the gas, is as important as it is up there, is an important finding, is a really key finding that's a bit surprising, that's really helped expand my understanding of kind of what may be happening, and how quickly a snow-covered mountain can become rock up there, even at temperatures well below freezing. So those are 2 points I would leave you with from a scientific perspective.
Yeah.
And then I guess from a technical perspective, I mean, you saw the photo of those wind sensors, and it's a challenge. These stations take a beating, and the folks, at Mount Washington on the observatory, they know this day in and day out and see this. But it's a huge challenge, engineering and maintaining sensors in these kind of environments.
Yeah, well, we do have a couple people wondering, hey, how MWO uses pitot tubes? Why don't you use that? But yeah, obviously challenges there. And boy, it'd be nice if you had a year-round fully staffed observation, someone going out every single hour, et cetera, et cetera. All right, last question for you. Sort of relatedly to that last point, Julia asked, she says, well, as a climber, curious if you've heard from any of the Sherpa who've helped supported your expedition work, or from Conrad or any other, long-time climbers in the region. How is mountaineering changing based on some of these conditions that you're aware of? I don't know if you're privy to any of that sort of chatter in the community.
Yeah, I mean, some. And for example, I've been told that the Lhotse face is this is 5,000 vertical feet from Camp 2 really up to the South Col. It doesn't have as much snow on it as it used to, and it's more ice, or really hard packed snow, and that makes it more challenging. There's more exposed rock in places as well, which crampons and rock just they don't go very well together. It's really challenging. And then of course there's the hazard with serac falls and just glacier collapse, and just instability within the ice fall itself, which is certainly something that people are aware of and concerned about in the context of the warming and the climate change, for sure. So those are some aspects that I'm familiar with.
Well, hoping the best for you and your team, especially, the more data you can collect, obviously the more time that these stations are on the ground, hopefully the greater value and insights that the scientific and climbing community can gather from this information and beyond. So with that said, Baker, hey, I just love to say thank you so much for taking the time tonight to share about your work and share about it with our audience. It definitely means a lot. I know a lot of super fascinated individuals that shared lots of questions this evening that we didn't have a chance to get to tonight. But as I mentioned, if there are any questions that are lingering out there, please feel free. You can reach me directly at education@mountwashington.org. Thank you all so much for joining tonight. If you enjoyed tonight's free program, we'd strongly encourage you to make a donation to help support programs like these over at mountwashington.org, and hit the donate button in the upper right-hand corner. And don't forget, a donation in any amount also makes you a member of Mount Washington Observatory. If you have any thoughts about tonight's program, suggestions for future topics or speakers, feel free to take some time, fill out the Google Form survey that'll follow this Zoom program tonight, and then the thank you email later on. Don't forget to join us next month for another mountain weather themed program on February 8th, where we'll be joined by the observatory's very own library curator, Dr. Peter Crane, who's going to be talking all about 19th century weather observing on Mount Washington. So don't forget to join for that program. You can register over at mountwashington.org/SITM and miss any of the other program or get to any of the programs you might have missed. Thanks again, Baker. Have a wonderful evening. Enjoy the snow down there. I know we're thankful for it up here too. So have a great night and thanks again.
Thank you, Brian. Everyone, have a good night.
Take care. Bye, everybody.